Hey guys, welcome to another video. Today's learning objective is about expanding products of two or more binomials, and the more is for higher tier only. So as usual, feel free to skip to any part of the video if you've seen what's going on and you just want to skip to some of the worked examples. The timestamps are here as usual. So before we get into some prerequisite learning stuff that you do need to know, really important if you to cover the previous videos that we've done. So far we've talked about stuff like, what is algebra and talking a bit about variables and the introduction to algebra. Then we moved on to some algebraic notation, saying why something like 5 times y can be written as 5y, or something like, xy being the same thing as yx, and that kind of stuff. And then we talked a bit about, collecting terms, and how, for example, using our example of Drake and banana. So if you hopefully you remember that kind of stuff. And most recently, our last video, we talked about expanding out brackets and factorizing. So especially that last video, it's really important to make sure you have a solid understanding of that before we go into this video. So let's talk about a learning objective: expand products of two or more binomials. So some terminology here. Ooh, red pen. So products. You might have heard this one before. Product is this when you multiply two things. So the product of 2 and 5, for example, just means you do 2 times 5. And so likewise, the product of, say, x and y is x times y, which is xy. So that's all product means. It's when you multiply, some different terms together. So it could obviously be a product of 3 things. So if you ask the product of x, y, and z, that's x, y, z. Okay, binomial. You might not have heard this one before. It's might be a new term. It's something like, for example, x plus 7, or 5y plus 8. And this is basically a binomial is when there's these two terms, say an x term and a constant term. This is the x term and this is the constant term. And binomial, right? If you think about where the word comes from, bi meaning two, so there's two things here. And the nomial, so it's compared to, say, something like a polynomial. So a polynomial might be x squared plus 5x plus 7. And the reason this is a polynomial is because there's more than 2 different terms. And since, remember, we can collect like terms, all the x's will be in this term here, all the constants will be like this. So i.e. there might be an x squared term, which you can't collect. So now there's 3 terms. Or for example, there might be an x cubed term, which you can't collect any other one. And so this is a polynomial, i.e. more than one poly. And binomial just means that there's 2 of them. So what's key here is in polynomials is that you've got raising powers. And sorry, that's x to the 1. And remember 7, if you think back to our laws of indices videos, x to the power of 0 is just going to be 1. So this is x to the 0, x to the 1, x to the 2, x to the 3 in a polynomial. But in a binomial, you'll have x to the 0 and x to the 1 only. Okay, so now we know what our definition is. Let's talk a bit about expanding binomials and the product of binomials, sorry. So say you've got something like one binomial, x plus 4, and you need the product of it with x plus 7. Okay, well, we can remember our distributive property, I guess. You go x plus 7, and then you can times it by x. So just think of this as one term for now. So you have x plus 7 times by x. So x into x plus 4. And we can do this again with x plus 4 times by 7. Plus 7 x plus 4. And if we expand that out a bit more, we get x squared plus 4x plus 7x. Let me change back to colors. So we have, if we expand that, we get that. And then we can do this again, 7x plus 7 times 4, 28. And then we can collect these like terms here. So the x, let me go back to black pen actually. X squared, 7 plus 4, 11x plus 28. And there we go. Sorry if you see me jump there, I just had to have a sneeze so the video got paused. So yeah, that's all there is to expanding binomials out. And what you get is you expand this binomial, and now you've got a cheeky polynomial. So expand out, sorry, two of these binomials. So there's actually a bit of a shortcut to this as well. So let's do this again. We've got x plus 4 and x plus 7, right? So instead of going to this step, if you look at what we've done x plus 4, so we've done two distributive things, right? We've done kind of this initial x plus 4 times by x and then plus 7, and then we've done that kind of x plus 4 times by 7, right? So we've done those kind of in two separate stages. Well, we can actually just combine this into one stage, because if you look at what we're doing is, for example, in this first one here, the x plus 4 times by the x, what we're doing is x plus 4 times x, which is x times x, plus 4 times x. And then we're doing, in the next stage, in this one here, we're doing the x plus 4 times the 7, right? So then x times, which is x times 7, and then 7 times 4. So we can kind of just do this in one big step. So let me draw this out a bit more clearly. Back to that. So we have x plus 4 and x plus 7. So if we were to do this all in one step, what we do is x times x, and then 7 times 4, x 7 times x, and then since we've done the two x's now, we can do kind of 4 times, change the color again, 4 times by x, and then 4 times by 7. Oh, so that's the same color, isn't it? Okay, there we go. So those are so we end up with 4 different terms, right? We have an x squared term done, and then we'll have 2 x terms, because we have the x times by 7 here, so plus 7x, we have that, and then we have the x term from here, 4 plus x, and then we have the final term here, plus 28. And so actually there's a bit of an even further shortcut here. So let's actually look at another example where we can talk about this shortcut. Say we have 2x plus 8 and 4x plus 9. This is a bit of a harder example, actually. What we could obviously do is kind of the process of what we did here, but in general, we know that the final answer is going to be in the form of x, something x squared, some coefficient, plus something x, plus something with kind of x to the 0, i.e. nothing, right, i.e. 1. And if we look here, what the coefficient here comes out to be, in front of the x squared term, is the coefficient of x, of this x times by this x, so i.e. 1 times by 1, which is 1. The 7, so the 7 plus 4, sorry, I didn't simplify this, plus 11x. The 11x comes from we have the 7x plus the 4x, so we have this term plus this term comes out to the coefficient of here, and the final coefficient is this number times this number. So knowing this, we can kind of fill in these blanks here. We know the coefficient for x squared will come from the coefficient of this x times by the coefficient of this x, which is 8. We know the coefficient of this x term will come from, if we do, okay, so I didn't really think this example through. Oh my days. So there's actually a further shortcut we can take. And to kind of see why, we're going to stick with this example and do it one more time. So we had x plus 4 and then x plus 7, right? And our answer came out to x squared plus 11x plus 28. So when we work through this, it kind of, we can see why, for example, that the coefficient in front of the x squared is the same thing as the coefficient here times by the coefficient of this x term, of these two x's. Because to get x squared, we multiply this one by this one, right? So we get x squared. And so if there was another coefficient here, for example, say it was 2x times by 3x, well, the coefficient of x squared will become 6x squared, right? So, but since we know the coefficient is 1 in both cases, we'll get a coefficient of 1 here. And now, where does this 11x term come from? Well, this 11x term comes from when we multiply the, let me change colors real quick, when we multiply this x term, sorry, when we multiply this x term by this 7, and this x term by this 4. So that will become, so, wrong color. So that will become 7x, i.e. and then 4x, right? And then, so the coefficient here is the coefficient of this number times by this one here, and then the coefficient of this times by that, which is 1 times 7 plus 4 times 1, which is 7 plus 4, which is 11. And the final number, we get to 28 when we multiply the 4 by the 7. So we get 28. And now let's think of this a bit more generally. Well, actually, let's do another example first before we think about this more generally. Say we have something like 2x plus 4 times by 3x plus 5. Remember, so in general, we know we're going to get something like something in front of the x squared plus something in front of the x plus some other term times x to the 0, which is just 1, right? That's a general form these two binomials multiplied out will come to. Okay, so remember, how do we get the x squared? We get the x squared when we multiply this 2x by this 3x. So that becomes 2x times by 3x, which is 6x squared. So the 6 goes here. There's no other way we can get the x squared term, right? Because if we do, say, 2x times 5, we get 10x. So that's not, there's not enough x's to become x squared. So the only way we get x squared is if we do this x term times by this x term. Okay, how do we get this x term? The only way we can get the x term is if we do this 2x term, then multiply it by 5 here, and if we do this 4 term times by the 3x here. And so, look, that's going to be 2 times 5, which is 10x, plus 4 times 3, plus 12x, which is 22x. So, let me just get rid of this working, so the next one becomes a bit clearer. So, 22x. So, remember, to get this one, we do this term here, multiplied by this, plus this, multiplied by this. Probably best not to, yeah, wait. I hope that one make sense. And this final, to get kind of x to the 0 coefficient, where there's kind of nothing there, the only way we can get a term without x is if we do 4 times 5, which is 20. So this is a bit of a shortcut to kind of skip from straight to here to here. It takes a bit of your mind to get wrapped around into it. And I hope that I'm going to do a general case to see why this kind of works a bit more generally. So if we have something like, say, ax plus b times by cx plus d. Okay, so if we multiply this out, remember we do ax times by cx. So ax times cx, which becomes acx squared. And then we do ax times d plus a, so it becomes adx plus adx. And then we do b times cx, so bcx. I know that's not exactly too visible. And then we do b times d plus bd. So in general, we get to then we get to something like acx squared plus ad plus bcx plus bd. So I guess if you memorize this formula in a sense, you can kind of almost always go from here to here. But it's quite helpful to remember the intuition behind it and the way we arrive to this. So kind of, while it's helpful to sometimes have the shortcut, it's important, you can kind of, it's pretty easy to see how you can kind of almost forget this. So it's quite helpful to just remember where the intuition comes by, and you don't have to use a shortcut. It's just, if kind of the shortcut makes sense to you, then feel free to skip to it and use it. But if not, the original method works kind of perfectly fine and kind of make sure you won't make mistakes, silly mistakes here. So if you want to do this, like, feel free to, but if not, don't. So let me do kind of another worked example with another binomial, and if you can kind of pause the video, you have to go at this one. So 4x plus 1, 3x plus 2. Okay, so just pause the video, expand this out, see how this works. You can use kind of any of the methods I've talked about so far. You can use a kind of shortcut method I talked about, or you can kind of go back to basics and say, you know, we do 4x plus 1 times by 3x and plus 4x plus 1 times, times 2. So pause the video, give it a go. Okay. So I'm going to use kind of the original method, the first method I talked about. So we do 4x plus 1, and then we times it by 3x, and then plus 4x plus 1 times by 2. So remember, this term out here times by that, and this term times by that. That's all we're doing. So let's switch back to it. So that becomes 12x squared plus 3x plus 8x plus 2, which becomes 12x squared plus 11x plus 2. And there we go. Now the hierarchy here also asks you to do 2 or more kind of binomial. So in the situation where you would have a question like 4x plus 1, let's say 5x plus 7, and then 12x plus 9. And the key here is to kind of not to be too phased by it. It looks pretty complicated, but if you work through this stuff slowly enough, you'll be able to ensure you get the right answer. So to do this, what I do is I just take 2 brackets, say the first 2, I expand those up first, and then I tackle it with a 3rd bracket. So what I'll do is, I'll say this is the same thing as kind of these 2 times that. So what I'll do is on the side, if I have to, I'll do 4x plus 1 times by 5x plus 7, so expand that out. So 4x plus 1 times by 5x, and then we'll do, so 4x plus 1 times by 5x plus, and then 4x plus 1 times 7. And if we 4x times by 5x, 20x squared, and then 1 times 5x plus 5x plus, and then 7 times 4, 28x, 7, see, this is the issue with having poor handwriting. You get confused what this is. That's a plus 1. So 7 times 1 plus 7. And now if we kind of collect all of those, we have 20x squared, 28 plus 5, what is that, 33, plus 7. Okay, and now we do this, then we have this original term, that therefore 4x plus 1, 5x plus 7, 12x plus 9 is the same thing, because we expanded this out into 20x plus 33x plus 7 times by 12x plus 9. Okay. Now again, the same process. 12x plus 9 times by 20x. So let me make a bit more space. So 12x plus 9 times by 20x plus 12x plus 9 times by 33x. So I'll just underline 33x now, plus 12x plus 9 into 30. Again, really important to have clear handwriting, because in these it's kind of quite easy to lose a term along the way, and then your answer can come out wrong. So it's really important to kind of take this step by step and make sure your handwriting is clear and kind of you know what's going on. You keep track of terms, and in doing so, kind of it's helpful to sometimes underline stuff, kind of just depending on your personal preference. And then plus 12x plus 9 into 7. Okay, let's expand everything out. Okay, 12x times by, see, look at me, I forgot the x squared here. So that's an example of kind of where you, commands. where you might go wrong. So kind of really important, even to copy this stuff correctly. So 12x times by 20x squared. Well, what is that? 12 times 2 is 24, and then times by 10, so 240x squared. So x cubed now. And then 9 times by 20x squared. Okay, 9 times 2, 18, so 180x squared. Plus 12 times 33. Okay, well, I'm just going to do some cross multiplication. So 2 times 3, 6. 1 times 3, 3. Again, it's going to be 36. Oh, sorry. 1 times 3 is 3, and 1 times 3. So 396. Wait, sorry. So we do that, and that's 6 there. So 2 times 3 is 6, and then and then 3, and then 3. So 396. So 396x, and then 9 times 33. Again, a bit of cross multiplication never hurts, so just check. 9 times 3, 27. Carry the 3. 9 times 3, 27. So 30. So 307, I guess. 307? Does that seem right? So the reason it kind of seems a bit weird to me is I know, for example, so I've clearly made a mistake here, and the reason I can tell I made a mistake is I know 30 times 9 is 270, and then 3 times 9 is 27, so that should come out to 270 plus 27, which is 297. So I don't know how I managed to get that. So 3 times 9, 27. 27, so carry the 2, right? Not the 3. So 29, there we go. That's a mistake I made. So it's kind of, it's helpful to see me make a mistake sometimes. I'm not saying that just to cover myself, but kind of in the sense that, with these things, it's really easy to make mistakes here. And the only way you can kind of avoid mistakes is if you kind of have this sense of what's right and wrong, I guess. Because if you look at 33 and 3 times, 9 is 27, so 33 times 9, kind of, it shouldn't be over 300, kind of just having that feel for things. It just means you avoid mistakes. So kind of through my mistake, you can see how you avoid mistakes, I guess. So 297x plus, and then 12 times 7, okay, so 70 plus 14, which is 84x, and then 7 times 9, which is 64. And then we can add all this up, so I'll have to sort of make some space. Get rid of this. So 240x cubed, that will stay the same. And then we have to collect the x squares. So 180 plus 396. My mental math is not good enough for that, I'm afraid. See, look at that. 396 plus 180. 6, 9 plus 8, 7, carry the 1, 4, 5, 5 plus 5, 7, 6, x squared. And then 297 plus 84. So 7 plus, 11, carry the 1, 10 plus 8, 18, carry the 1, 381. 381x plus 64. And kind of the ways you can check this as you go along. So if you kind of expanded this out, right, you should, so remember how I forgot the x squared term out here? You should know kind of, if you've done it in this way, it should come out. So you have one x cubed term, two x squared terms, two x terms, and one kind of final term. And kind of doing it this way, just as a quick check while you are doing this, just make sure you've got two x squared terms, two x terms, one of kind of x to the 0 terms, and one x cubed terms. And then hopefully kind of, hopefully your mental math is a bit better than mine and kind of can carry it through. But really important to go over this and check, because this is the kind of, in these questions, it's super, super easy to make mistakes, especially kind of, by miscopying stuff, that kind of stuff. So important to have very clear handwriting here and kind of just make sure you write and copy things out correctly. There's so many silly mistakes I've lost in questions like these because I copy stuff out wrong, I multiply things out wrong. So it's super important kind of with these questions, you guessed what I was going to say, make sure you practice, because through practice you get this kind of second nature feeling to it, where you can kind of tell something's feeling a bit wrong. I've done questions before and kind of the answer was slightly different to this, and that kind of stuff, and having that almost like, I guess, like spidey sense of knowing when things are wrong really helps you out in questions like these. So kind of doing that, let's actually go back to our quadratic equation we had. So remember this, say something like, where is it? Something like this, right? Remember how last video we expanded out, but we also talked about factorizing. So what we'll do next video is actually we'll go, how we've gone from here to here. We'll actually be talking about how to go from here to here, and next video will all be about kind of factorizing quadratics. So I hope that video made sense. I know it was kind of a lot to take in, a lot of new different concepts covered, but again, with this, literally all it is kind of the process itself is pretty simple. It's just making sure you get it right and you don't make those silly mistakes. And the only way you can avoid silly mistakes in the exam is kind of having your exam technique on point, but also kind of just having done enough of these questions so you can tell when something's wrong. But kind of hope that made sense. See you guys in the next video.